Hello everyone. In this session, I am going to take merge sort algorithm in detail. In the last classes, we have discussed about the basic concept of merge sort algorithm. You know that this merge sort algorithm is using the strategy divide and conquer. And you know the basic abstraction used for the divide and conquer strategy. Okay, so I will be just giving a small hint regarding divide and conquer strategy here. What is happening? You have a big problem with you have a big problem P with you, and you are going to divide the problem P in such a manner that you are getting only single element in that problem P. Okay. So when your problem P contains only a single element, it is very easy for you to solve that problem. Okay. So after getting the sub solutions for all your sub problems, what you are going to do at the end of the divide and conquer strategy, you are going to combine all these sub solutions together and you will get the final solution for your original problem P. Okay, so that is a basic concept regarding the divide and conquer strategy. So we know that there are different problems are there where we are applying divide and conquer strategy. So under the term sorting, we have different sorting algorithms are there. So merge sort and quick sort are going to use a divide and conquer strategy. So in this session, I'm going to take merge sort algorithm in detail. So let me share first the algorithm related to the merge sort. Okay, so let's see. We have an algorithm, and that algorithm is for a merge sort. Okay, so the basic, so you know that this merge sort algorithm is going to apply divide and conquer strategy. You are going to apply divide and conquer strategy, and this. Uh, Let me share the PPT for your merge sort algorithm. Okay, just a second. So what happens? This merge sort algorithm. This is a algorithm that you have to use. Just a second. Yeah, this is the algorithm. Okay. So here you can see this is the algorithm related to. Hope you are able to see the screen shared by me. This is the algorithm merge. So first of all, what you have to do, you have to write this algorithm in your notebook. So you just pause this video and try to jot down all these statements, statement 1 to statement 31 in the same sequence in your notebook. Okay. After writing this merge algorithm, you see this is a merge algorithm, and let me make it bold. This is an algorithm merge. Okay. So you have to, there are three parameters are there: low, mid, and high. And what is the importance of low? What is this low indicate? Low indicates the lower index of your array. Okay, and mid is the mid value, mid index of that array, and high indicates the higher index of that array. Okay, so this is low, mid, and high, three parameters are there. And inside this algorithm, you see different statements are there. I will be explaining each one of these statements later in this session. Okay, so you have to jot down this algorithm first in your notebook. Hope this is clear to you. So just pause your video and then jot down the, just pause your video and then you just write down. Okay, so let me move on to the next slide. Here you have this you have another video here. So sorry, this page here you can see this page. I have already share this PPT with you, and in your page number 145 you will get merge sort algorithm. Okay, this is merge sort algorithm, you see. So here you will find this page number 145, you will find this merge sort algorithm, all the basic. You have to use this sheet, means this page of your textbook, to write down the notes for the merge sort algorithm. Okay, so all the basic concept is given here. So when you are going to, now you have to write down this algorithm. You just have to write down this algorithm. Okay, this algorithm merge sort. So in your notebook, first write down algorithm merge sort. This is the first algorithm you have to write down in your notebook. Okay, this is the first algorithm. You can, and in as the second algorithm, you have to write algorithm merge that I have shown in few minutes ago. So that means this merge. Okay. So by pausing the video, you have to jot down the algorithm merge as well as the algorithm merge sort in your notebook. And this PDF is already shared with you earlier. Hope this is clear to you. Now I am stopping sharing this screen with you. Okay. So the basic plan of this merge sort algorithm is that you are going to divide the whole list of array. You are having one array with you, and you are going to divide the list into two halves. And after that, what you are going to do? After that, you are going to solve the two halves recursively. And the third step is that you are going to combine these. You are going to combine these two halves and get the final solution for your original problem P. Okay. So the basic plan is that we are going to divide the array into two halves. Then recursively we will sort each half, and then we will merge two halves. Okay. Hope this is clear to you. So this is the basic plan regarding the merge sort algorithm. So I will be sharing one screen with you right now, and you just jot down these points in your notebook. The basic plan regarding the merge sort algorithm. See, the first one is this one. You have to divide an array into two halves. This is your input array. Suppose your array contains these number of elements. Okay, all these are alphabets. And what you are going to do the next step, you have to recursively sort each half. You see this partition is given here, and this you have to sort the left half. So this is the left half sorted, and then you have to sort the right half. Okay, and after that you have to merge two halves. So you can see this list left half is sorted and this right half is sorted, but as a whole these are not sorted. So final you have to sort, you have to merge these two halves, and you have to get the final sorted list for your original problem P. This is your original problem P, and this is your final result. Okay, hope this basic plan is clear to all of you. So let me stop sharing the screen with you. Now I am sharing the whiteboard with you right now. Okay, I will be taking one example, and I will tell you how to sort a list of elements using merge sort. Okay, so before that, means when you are going to use Ellis Horowitz textbook or the PDF that I have shared with you earlier, it is too difficult for you. It will be very difficult for you to understand that algorithm as such. Okay, I have discussed, I have shown you two algorithms there. That is algorithm merge and algorithm merge sort. Okay, so that algorithm merge is a lengthy process. There so many steps are there. Hope you remember there are 31 steps are there in that merge algorithm merge. Okay, calculating including all that comments and all things. Okay, so what is happening in this merge? There are two algorithms are used. First is the, what is the first algorithm? The first one is the merge sort. Okay, merge sort algorithm is there, and second one is a merge algorithm. Okay, and this one is the hottest point of a merge sort algorithm, merge sort process. Okay, that means in the case of the merge sort algorithm, what is happening? Division is happening. Division of list is happening. Division of list is happening. Okay. But in the case of algorithm merge, what is happening? This is the hottest point of merge sort algorithm. That means here what all things are happening? Here the sorting is happening. Sorting is happening. Okay. And combining. You have to combine the solution, sub-solution. And that is also happening here. Sorting is happening and combining is also happening. Okay. Hope this is clear to you. Combining is also happening. So these are the two important algorithms, merge sort and merge. So when you see the Ellis Horowitz textbook, what happens? This algorithm merge is very difficult to understand the first time you are going to use the Ellis Horowitz algorithm. So making it less complex, I am giving you another short algorithm to make you understand the original process that is happening inside the algorithm merge. Clear? So let me give you that algorithm first. So all of you, please write down with me when I am writing this. Okay, so just omitting this one. So clearing this all things. Okay, so algorithm, you write down like this, algorithm merge. And here we have an array A and we have small p is there, small q is there, and small r is there. Okay. So what is A? Capital A indicates a array, original array where your input data is stored. Small p indicates the lower index of your array. Q indicates the upper index of your array. Sorry, your Q indicates the mid index. Okay. And R indicates the upper index of your array. Clear? A indicates the array name where your original data is stored, unsorted data is stored. P is the lower index of your array. Q is the mid index of your array, and R is the upper index of your array. Clear? So here we have one small n1. This small n1 means you are going to calculate the number of elements present in the left half of your array. Okay, so that total number of elements present in the left half of your array. So suppose you have a two array. So why you are using this merge algorithm? You are using this merge algorithm to combine the two halves and make it sorted as a whole. Okay, to combine the two separated sorted arrays and make it sorted as a whole. That is the purpose of merge algorithm. Okay, I will write down that points. To combine two sorted arrays, subarrays, two sorted subarrays, and combine them into one sorted array as a whole. Okay, this is the purpose of your algorithm merge. Hope this is clear to you. Please write down this statement. Now I am omitting this one. Okay, so this n1 is the I will explain this algorithm with example. So this n1 is the total number of elements present in your left half. So suppose we will get that half by this q plus this q minus p plus 1. I will show you all the calculations. Then we have n2 where you are going to get the number of elements present in the second half of your list, r minus q. Okay, and now this merge sort algorithm uses temporary arrays for sorting. Okay, so we have two temporary arrays, and that is let L may have one array which is going to store all the elements present in the left half of your array. So it will contain all the elements with n1 plus 1. Okay, and then we have another array R which is going to store all the elements present in the second half of your array. Okay, and these are two new arrays, two new temporary arrays. Okay, so you see the index for L is 1 to n1 plus 1. Extra space is needed. I will explain you why you are going to store extra space for that L and R. Okay, so I will explain that later. You just write down all these things. And then we have a for loop with us. We have a for loop, and that for loop I is equal to 1 to n1. Okay, and inside this for loop we have only one statement, and the purpose of this for loop is to copy all the elements present in your left half into your new temporary array L. Okay, you are going to copy all the elements present in the original left half of your array to your new temporary array L. So that is happening in this process. Okay. So you have this one, P plus I minus 1. This is the only thing happening in this for loop. So similarly, we have another for loop to copy all the elements present in the right half of your original array and copy that elements into the temporary R array. Okay, so that is happening here. J is equals to 1, 2, and 2. Okay, N2 is what? N2 is the total number of elements present in the second half of your original array. So this is what happening here. Rj is equals to in Q plus J. Clear? So what is the purpose of these two for loop? The purpose of these two for loops are, the first for loop is going to copy your left array elements into new temporary array L. And the purpose of second for loop is to copy right array elements to your new temporary array R. Okay. So after copying this, what you have to do? You have to, yeah, you can see that we have used one extra space for L. Okay. We have only n1 number of elements present in the left array, but we are going to give one extra space for temporary array L. Similarly, we are going to give one extra space for your temporary array R. So why you are going to do that? You are going to fill that extra space with infinity value, with a very big value. Okay. So your n1 plus 1 is equals to infinity. You are going to use one infinity symbol. Okay. So here, as I am not I am not getting infinity any value here. Just for infinity, I am putting this symbol. Okay. Just a second. This symbol. Clear? You just think that this symbol is used. This is your infinity. Okay. You have to put the symbol of infinity. Now we have an array. R is there, and similarly the last element of that array is filled with infinity value. Clear? So now what you have to do, now again we are initializing our I with 1 and j pointer with 1. Okay. And now just move, I'm holding, hope you are able to see all these things. Now small statements are there, one another final for loop is there for k. K is equals to P to R. P to R. P is your lower index, R is your upper index. Okay. And here, what happens? You have to check if L of I is less than or equal to R of J. If your L of I is less than or equal to R of J, what you have to do? You have to take that element and place it at kth position. A of k is equals to L of I. Okay, and you have, since you have taken the element from your L array, you have to increment your I value. I is equals to I plus 1. And if suppose that condition is not true, what you have to do, you have to go for the else part. That means your L of I is greater than or equal to R of J. If that is the case, you have to copy the element from your temporary array R and put it in A of K. Okay, A of K equals to R of J. And since you have taken the element from your right half, you have to increment J is equals to J plus 1. Clear? So this is the end of your for loop. Hope this much is clear to you and this is visible to you. Hope you have already written all these things. So this is the algorithm. Okay? Clear? So hope means as this is a video, you have to pause the video to write down the algorithm. So now I hope that this algorithm is in your notebook. You have to clearly understand this. This symbol is used for infinity purpose here. Okay. So now I will be taking one small example and I will tell you how this algorithm is actually working. Okay. So just a second. Just a second. I will erase all that thing. clear all things. Okay, I'm clearing all the algorithms. And now I am taking one example. Okay, suppose you have an array A. You have an array A and you have 6 elements in that. Okay, you have 6 elements. I am drawing 6 elements in that array. This is your array A. We have 6 elements in that. 1, 2, 3, 4, 5. So let me do the numberings. So this is your array index 1, this is your array index 2, this is your array index 3, this is your array index 4, this is 5, and this is 6. Okay, let me put all the numbers inside this array. Suppose you have array numbers, in your array you have numbers like this: 9, 6, 0, 5, 2, 5, 2, and what else we can put it here as 1. Okay, let it be 1. Clear? So we have 6 elements with me, and these are 9, 6, 0, 5, 2, 1. You are going to apply merge sort algorithm here to solve this list of unsorted elements and make it a sorted list of elements. Okay, so let us see how we are going to solve. So when you see the merge sort algorithm, what happens? In that merge sort algorithm, what is given? Merge sort, you just check your notebook where you have jotted the merge sort algorithm, the original main merge sort algorithm. Inside the merge sort algorithm, you are going to call merge algorithm. Okay, so you can see that inside the merge sort algorithm, what is the first condition checking there? It is you are checking where your low is greater than high or not, where your low is greater than high or not. Okay, so low is means what? Low is your lower index and high is your upper index. So here your lower index is 1 and your upper index is 6. So 1 is less than 6, the condition is true. So the condition is, since the condition is true, what is the next step inside that merge sort algorithm? You are going to calculate the mid value. And how you are going to calculate the mid value? You are going to calculate the mid value by mid equal to low plus high by 2. So here 1 plus 6 by 2 is 7 by 2, that is 3.5, and you have to take the integer part only, that is 3. So your mid value is 3. Okay. And next you are having merge sort, the function you are going to solve the sub problem. So merge sort is applied here, and merge sort low comma mid is there, and second merge sort is also called, and the parameter used are mid plus 1 comma high, and the third time you are going to call the merge. Okay, so hope you are with my you have what you have to do with my this video. You have to open your notebook. You have to follow that algorithm also step by step. Okay, so hope that algorithm is in front of you. Clear? Now, so this is a list of elements. So here the condition, since the condition is okay, what you have to do? So since the condition is okay, you are getting the mid value. Mid is equals to, what is the value you are getting as mid value? You are getting the mid value is 3. Mid is equals to 3. Okay, that means what? You are dividing your list. This division is happened here. This much. This division is happened here. Okay, so you got this mid equals to 3. Now you are going to use I am writing MS for merge sort algorithm. Okay, so in the merge sort algorithm, what is that? Low comma mid. And what is low here? It is 1. Okay, comma. And what is the mid value? 3. So you have to go, first you have to complete this task, merge sort 1 comma 3. You have to complete this task first. Then only you will go to the second merge sort calling. That is in your algorithm you can find, you have another merge sort and the parameters are there are mid plus 1 comma high. And what is that mid plus 1? That means 4 comma high. What is high? That is 6. Okay. So first you have to complete this. Then only you have to call this function and you have to complete this function. And then only you have to call the merge algorithm, merge. And in the merge algorithm, what are the parameters? The low and your mid, and then your, what is your upper index? That is 6, high. Okay. So first thing you have to complete this task. Listen very carefully. First, you have to complete this task. That means you have to complete this task first. Then you have to complete this task first. And then only you have to call this function. Okay. This is how your computer will take these functions recursively. So since you are going to since you are going to call this merge sort 1 comma 3, that means this one, you are focusing on to this portion only. Okay. So again, you are calling merge sort with low and high. This is your low and this is your high. What is happening in low comma high? What is happening? So again, inside the merge sort, what is the checking? If low is less than high, yes, yes, you can find that 1 is less than 3. So the condition is true. So again, you are going to calculate the mid value and you will get the mid value. What mid value you will get? You will get the mid value 1 plus 3 by 2, that is 4 by 2 is equals to 2. That means again, you are 2. So this division is happening here. This division is happening here. Okay. So this way again, that means your merge sort you have to write like this: merge sort 1 comma 2, and then merge sort low plus mid plus 1 comma high. And what is mid value here? 2. So 3, and high is 3. And then you have to call merge. Okay. So what is a merge? 1, low, mid, and high. Okay. Low, mid, and high. So these are the 3 function calls happening when that merge sort is called. Okay. So here also you have to complete this task first, then you have to complete this task first, and then you have to complete this. Okay. So when these 3 tasks are getting completed, you are completing this one. Okay. So these are the so I will, so what I am going to do right now, I am going to draw the tree structure. Okay. For this. Be with me. Don't get changed. It is so easy. It is very easy. Okay. To learn. So what is the thing? You are having merge sort. You are applying merge sort algorithm for 6 elements. 1 comma 6. Okay. So I am going to write the tree structure. So after, when you are applying the merge sort on 6 elements, what are the 3 things you are getting? These are the 3 things you are getting. Merge sort. These are the, so low comma mid, low value is 1 and mid value is 3. Okay. And here merge sort. What is the next parameters? Mid plus 1 comma high, and mid is 3. So 3 plus 1 is 4. Okay. So 4 comma 6. Please don't mind the handwriting that I'm showing here. And this is a merge algorithm. So merge is indicated by M and merge sort is indicated by MS. So merge, in the merge you have 3 parameters. Low, this is 1. Mid is your 3 and high is your 6. 3 comma 6, 1 comma 3 comma 6. Okay. So just a second. I want to make it more clear here. So 3. Okay. Now, so first you have to solve this merge sort 1 comma 3. So what happens? Again, this, when you are invoking merge sort 1 comma 3, you are splitting. So you are getting 3 function calls there. So you have to solve these 3 function calls. So 1 comma 3 means a merge sort. So low comma mid is this. So low is 1 and high is 3 here. So you are going to calculate. So 1 is less than 3. The condition is true. So again, you are going to calculate the mid value and you will get the mid value. So 1 comma 2, low comma mid. Okay. And here merge sort mid plus 1 comma high. So what is the mid plus 1? Mid is 2. 2 plus 1 is 3 and high is 3. Okay, and next you have to calculate a merge. So three parameters are there: low, mid, and high. So what is the low value? 1, low is 2, mid is 2, and high is 3. Okay, so again you have to draw these three branchings likewise. Okay, so since why you are doing this, so inside the merge sort algorithm, what is happening? Division of that is happening. Division of array is happening. Okay, you are dividing the list till you are getting only single element in your list. That is happening in the merge sort algorithm, and in the merge only you are going to sort the elements. Okay, so again you are going to merge sort in this for 1 comma 2. 1 comma 2 means this area you are focusing. So you can see here two elements are there, na? 9 comma 6 is there. So you are again breaking this element array into two subarrays. So when you are taking the you are taking the mid value, you will get 1 as the mid value. So 1 comma 1, and here ms, this will be 2 comma 2. Okay, and finally you have to merge this. So this is merge. What is low? Mid is 1, and that is high 2. Okay, so in this way you have to do. So you see this left half is, so when this task, this function gets complete its task only when all these functions are completing its task. Then after completing this one, it will come to 4 comma 6. That means this portion, right half. It will also split in the same way. All this splitting will happen in the same way, the way we did here. Okay, and after so many branches will be there. After completing all these functions, you are completing this portion. That means then you will get this list as sorted. So when you are completing this function, you will get the list as sorted. That means left half is sorted. When you complete this ms 4 comma 6, the right half is sorted. Okay, and finally you have to get the final sorted list. That is happening at the end of this calling, merge calling 1 comma 3 comma 6. Okay, so this is what happens in the merge sort and merge algorithm. So let me show how the merge algorithm works. Merge algorithm works. Okay, so you know that we have a 9, we have these elements 9, 6, 0, 5, 2, 1. These are the elements present in our array. Okay, so these are our array, and these are our elements present in that array. So what happens when our merge sort 1 comma 3 completes its task? Our elements looks like this. So this is the first division occurred. Now this was the first division occurred. This is our left array, and this is our right array. So when merge sort 1 comma 3 completes its task, what happens? The list will be like this. It will be like this: 0, 6, and 9. I'm removing this one. Okay, this will be the left array, and here what happens? We will have 1, 2, 5. 1. This will be the situation when you complete your merge sort 4 comma 6. Okay, so you see here the left array is sorted, the right array is also sorted, but whole total this is not sorted. We are going to call merge. Now the final calling is there: merge 1 comma 3 low, 3 is your mid, and high is your 6. So when this final merge is happening, then only the whole sorted list you will get. Okay, so let us see how you are going to do that with your merge algorithm. So just check your notebook where I have given you a special algorithm for merge with the arguments, with the parameters a comma p comma q comma r. So in that merge, what you are seeing, you have n1 is there, first n1. What is the purpose of this n1? This n1 will give you the total number of elements present in the left array. Okay, so what is the calculation? Q minus P plus 1. What is Q here? PQR. Q is your mid value. What is the mid value here? This is your This is your P, this is your Q. For your algorithm merge, for this algorithm merge, this is your PQR. Okay, so what is the calculation? Q minus P plus 1. What you will get? You just check what you will get. You will get Q is 3. 3 minus 1 plus 1. That means 3. So that means here the total number of elements present here is 3. 1, 2, 3. Yes, it's right. Okay. Hope this is clear to you. And now we have N2. The variable N2 is here. What is the purpose of this N2? N2 gives the total number of elements present in the right array. Okay. So again, the formula is R minus Q. So R is what? R is your 6. 6 minus 3 is a 3. Okay, 6 minus 3 is 3. So 6 minus 3 is a 3. So you can see that in the right array also, you have 3 elements present in your right array. So that is also clear. Now we have 2 for loops are there. What is the purpose of this for loop? So before that, you are going to settle that. You are going to you are assuming that you have 2 temporary arrays are there. L is there and R is there. So what is how many spaces you are providing to L? You are providing n1 plus 1 space. Okay, how many? And n1 is what? 3. 3 elements are there, but extra space you are providing. So that means 4 cells are there in L. And similarly, in case of R, the number of cells present in R is also N2 plus 1. N2 is equal to 3 here. So 3 plus 1, 4. So you are allocating 4 cells for your temporary array R. Okay. And what are you going to do in the first for loop? What is happening in the first for loop? You are going to copy all the elements present in the left array to this L array one by one. You are copying this 0 to here, 6 to here, and 9 to here. Okay, like this. So you just put down that elements here. So you are copying 0, 6, 9, and what you are feeding at the end. So this is blank right now. Similarly, you are copying all the right half elements to this temporary array R. So here 1, 2, 5 is there. Okay. And what is your feeding, putting at the end of this L array? You are giving infinity, a very big value, infinity. Okay. So these are the situations right now. And what is the next step in the algorithm? You can see you are pointing your I equals to 1. You are initializing your I is you are having one I where pointer variable is there. It is pointing to 1, and you are having another pointer variable and it is pointing to 1. So ing. So let us see what is the purpose of this ing. Okay. So just give me this. I is this is your 1, this is your 2 indexes. Okay. 4. Here also 1, 2, 3, 4. Okay. And this I pointer variable is for this L array. This is pointing to L array, pointing the first index of L array. Okay. And J is the another pointer variable which is pointing to the first index of your right array, temporary right array. Clear? Now just have a look into the last for loop of your merge algorithm. You have a variable k, you have a pointer variable k, and this pointer variable k is for this is your original array A, and this pointer variable k is used for this. Okay, let me take another color. This is k is your pointer variable, and this is pointed to the first index. This is your first index, 2, 3, 4, 5, and this is your 6. Okay, clear? Now you see what is how for loop is k equal to p to r. P is your lower index 1, r is your upper index 6. Okay, so 1 to 6. Now what is happening? Your L of I is less than or equal to R of G. So right now I is pointed to the first index of L, J is pointing to the first index of R. Now these two elements are compared. 0 is less than or equal to 1. If 0 is less than or equal to 1, what you have to do? you have to take the lesser value and copy that value into the original array A. So here you see L of 1, that is 0, is less than or equal to R of 1, that is 1. So 0 is less than or equal to 1. That condition is true. So in A of K is pointing to 1. Okay, that means at this location, what you have to do? You have to take this element and put it here. You are putting it here. Okay, you are overwriting that value in that first index of your original array A. So you can see here in the previous value is also 0. So there is no change, but that new value is overwritten here. Okay, now this 0 is not here. This 0 is there. This blue color 0 is present here. Clear? Now what happens, since you have taken the element from array L, you have to increment your pointer variable to the next value. And that is what written as I equal to I plus 1. Okay. Now your I is pointing to the second index of your array L. Now these two elements are compared. 6 is less than or equal to 1. Which is lesser here? 1 is lesser. So you have to take 1 from R and copy that 1 here at original array. Okay. A of K equal to R of J. Here R of J is R of 1. So R of 1, the value present in R of 1 is 1. You are copying that element. You are taking that element 1 and putting it in the position A of K. So your K is also updated. Okay, K is incremented, K is pointed here. So now your 6 is overwritten by 1. So you see, now the value 6 is not there. Okay, I'm removing all that one. So your array looks like this. Clear? Since you have taken the element from R, you have to increment G. Now these two elements are compared. Which one is less? 2 is less. So you are taking 2 from R and putting that 2 here. By that time, you have incremented the value of K also. So K is in the third index. So your new array, your array A looks like this. Okay, clear? Now, since you have taken the element from R, again you are increment to the J. So J is pointing to third index. Now this 6 and 5 is compared. And what is happening? 5 is less. So you are taking 5 from temporary array R, and that 5 is written here. By that time, you have incremented the K also. So your in array A, you will get these changes. Okay. Since again you have taken the element from R, so you have incremented the value of R, and now your R is pointing to the fourth index of R, and in that fourth index it is infinity. Now 6 and infinity is get compared. Okay, your I is pointed to second index of L, still it is at there. Okay, and 6 and infinity is compared. Which is lesser? 6 is lesser. So you are taking 6 from L and putting it here in your original array A. Okay, so what happens? Clear? And since you have taken the element from L, you are incrementing your I value. Now this 9 is compared with infinity. Which is smaller? 9 is smaller. Obviously 9 is smaller. So you are taking the element 9 from L and putting that 9 here in your original array A. So 9 is here. Clear? This way, you are getting your original array A as sorted. Look how, so now you see your, so since you have taken 9 from L, you are incrementing your I. Okay, and when this loop gets ended, now this infinity and infinity gets checked. Okay, and what happens? Your so since and when it is getting out from that for loop, it is coming out from the for loop, exiting from that for loop, when this I have already this K is already reached to the sixth index. Okay, so that automatically it's come out from that for loop. Okay, and after that you will see this list. Original array contains elements 0 1 2 5 6 9, sorted list. So this is how the sorting and combining of subsolutions are happening inside the merge algorithm. Okay, so hope this is clear to all of you. Just go through the PDF part of that chapter and then use this video to understand this algorithm. Okay. First, you understand this merge algorithm, the algorithm that I have written here in this whiteboard for the simplified algorithm. First, understand that how the working is going on for the merge algorithm. Okay. Later, we will do the algorithm present in your textbook. Clear? So, hope this is clear to all of you. If you have any doubt, you have to ask me today itself. Thank you. Pause the video number of time, understand it, and then if you have any doubt, jot it down and call me or text me and clear your doubts. Thank you. Thank you so much for watching this video.